Okay, now that you got your fair share of polynomial topics, you got your fair share of polynomial knowledge, let's handle one of these problems, which is one of my favorite in the AMC, simply because it gives you as little information as possible, and it's one of the equations that seems to be almost unsolvable, well, at least by my standards, yet with some manipulation you are able to solve it. Okay, what is the question saying? Well, you go take a read, is that we got a polynomial here, okay? And just writing it shortly, when we divide it by x take away 19, the remainder is 99. And when we divide it by the factor x take away 99, the remainder is 19. And that's it. And then after this, it will just tell us to find what is the remainder when we divide the polynomial by the product of x minus 19 and x minus 99. Now, the reason why I say that it looks like a very difficult question, because, well, firstly, it's the high degree of the numbers over here. I mean 19 and 99. It seems to project the problem as quite big, or certainly quite hard to solve, or that we need good arithmetic, but that's not the case, okay? Really, that's not the case. And then on top of that, the other thing that really seems that is hard to solve is because of this polynomial Pn. Now, why do I say that? Well, because there looks like there's very little information we know about the polynomial, sorry, Px, P in terms of x. There seems to be very little information we know about it, you know, and now we need to have the task of finding the remainder when we divide it by the product of these two, which looks even more difficult. But let me assure you that there's a few ways, there's only one way that we can do it, and it seems to be, you need to know a lot of understanding on the theorems, okay? Now we're going to employ two theorems to solve this, theorems which I went through to you in the previous concept page, but let's just go through it. Okay, the linear factor theorem. The linear factor theorem says that we can write the polynomial something in terms of something like this, divided by a linear factor, okay, and we'll be left with another polynomial, and then we will add with the remainder, sorry, PC, okay, PC over here like that. Okay, now this is the linear factor theorem. Now, why do I say that it even makes the problem seem more difficult? Because we certainly can't find this, and now that we don't know what the polynomial is, we certainly can't find that. Okay, but never mind, let's just take it in stride. Let's put the theorems down and see what we get. Okay, so this is the linear factor theorem. Okay, now what we can do about the linear factor theorem though is that we can find some results, because when we let a certain number, okay, be C, or when we let C be a certain number, we can really find out the result, okay, because of this remainder that we have, knowing that this remainder is in fact this one over here. Okay, I hope that many of you can see that. Okay, you see, we divide it by a factor over here, okay, and obviously the remainder is going to be a constant term. It's not going to be an x term, right? So it's going to be a constant term, and the constant term is going to be that. So let's just, by using the first one, x take away 19, okay, we got this one over here, and we got the remainder as 99, right? Okay, so that would mean that P19 is equals to 99. Why did I say that? Because we let C take 19, because we got the factor here, and we can put 19 over there. So we know that when we put 19 inside, we get 99, because 99 is the remainder. Okay, get familiar with the theorems. Okay, then doing it for the other one, following suit, we get this result here. So at least it's some progress. Okay, we got P19 equals 99, and we got P99 equals to 19. Even though that we don't have Px and Qx explicitly, but it shouldn't matter, because the next theorem that we're going to use is the general factor theorem, which is written as this. Polynomial x is equals to dx, okay, then it's times by quotient x plus rx here. Okay, so again, interpreted, we got a polynomial, we divide it by a certain factor or a certain equation in x to the power or to the degree of m over here. Okay, this is the degree of m, px is the degree of n, and qx is going to be to the degree of n, m minus n here, and the remainder is going to be to the degree of less than m. So you really need to get the whole formula down, really, as in know what's going on. Okay, again, it seems a little difficult because, like I said, we don't have px, we don't have qx. However, what makes this thing easy to solve, or what makes this thing, we're able to solve it, is knowing the fact, okay, that we can write dx in terms of these two, okay? And after that, we want to eliminate this one over here, and we do that by letting x be 19, okay? And then when we let x be 19 to eliminate this one over here, we can later bring x over here to kind of express this rx over here, okay? And keeping in mind that later we're going to use these two formulas again. Now, what I just said may not have made sense, okay? But let's just see what we have. Okay, dx, let's go. X minus 19 multiplied by x minus 99, okay? Qx over here, plus rx, which is less than m is equals to 2 because of the x squared. Be careful for that. So it's plus ax plus b. Okay, this is equals to px over here. Now, what do I have? I got p19, which is equals to 99. But what do I also have? I let x equals to 19. I eliminate this one over here. Can you see that? Because I can eliminate this, just like how a common strategy is to eliminate the ones that you don't know. In this case, it's qx over here. So I eliminate that. I put the 19 inside here. I get 19a plus b. 19a plus b, and I got my first equation, which I will write it as like that. Now, doing so for 99, okay, letting s be 99, I eliminate this one again because of this one over here. So I will get 99a plus b. Add them up, and what do I get? Oh, sorry, I've subtracted. I've subtracted this one from this one, so I got 80a equals to minus 80, a equals to minus 1, and b is equals to, let me just have a quick check. B is equals to, B is equals to 118. Equals to 118. And so the remainder would be minus x minus, plus 118. This is the remainder, okay? So it's minus x here. And there you go, how we solve a question like this, okay? Because this is the remainder is going to be a linear factor. So what's the strategy? Well, the strategy is really getting to know the formulas and to really suspect how we can eliminate those polynomials that we don't know. In this case, it is qx. We eliminate it by letting x be a certain value, and by using the previous results, we can get the remainder equals to the constant values over here. Solve for a and b, and there you go. That's how you solve.